Okay, I have a few examples here laid out for some probability density functions. First off, what the heck is a probability density function? So it's defined by this criteria over here. Okay, we're talking about a probability that something happens, and where x is between a and b. Well, if I'm talking probability of some function, right, I just kind of drew it in blue here, and the probability of a, is this, and then some other value is this, and b is this, right? Well, add up all those probabilities, and we're now talking about area under a curve, which is an integral. And that's where this formula comes from above, right? Probability from a to b is equivalent to the integral a to b of f of x dx. Now, a probability density function is defined first off that the function has to be positive. Why? Because we can't make sense of a negative probability. So f of x has to be positive since that's defining the probability of each of these events. One other quick thing to point out, notice this function is continuous. Right? Before now we only dealt with discrete, and discrete random variables would mean we only have a collection of these given events a to b, right, that's finite. I could count them, and I'd only have a collection of points. And we can't integrate a function that's not continuous. So that's why this section, it's important to point out that we do have a continuous function here, right? And last, that integral is equal to 1. What does that mean? That means we found, right, the sum of all the probabilities has to be 1. There's no other option out there. Okay. So let's look at some examples, like how does this work and how does this look? So the first question is just to verify that this function given, bounded by x between 0 and 1, is a probability density function, is a PDF. So we have to verify these two things. Is the function always positive? So is 5x to the 4th always positive? Question. It can be 0, but right, 0 or greater than 0. So looking at these values here, if I plug in anything between 0 and 1 into 5x to the 4th, right, then yes. Like if I plug in 0, I get 0. If I plug in 1, I get 5. Anything in between there is going to also be positive. So that criteria is met. Now, is the integral a to b, right, 0 to 1, of 5x to the 4th, does that equal 1? So I'm going to put question because I don't know yet. That's what we're trying to show. We'll integrate that. We get 5x to the 5th over 5 from 0 to 1. So the 5's cancel. We'd have 1 to the 5th minus 0 to the 5th, which is 1. So we verified that that function, 5x to the 4th, from 0 to 1, is the PDF. It is the probability density function. Okay, each of these are going to have a slight tweak to them. So the second one, find k that makes this function a probability density function. Okay. So first off, we want to make sure it's always positive. Well, the only way f of x squared, or kx squared, would be negative is if k were negative. So for criteria 1, we know k has to be positive. And I want to even say, right, just greater than 0, because if it were 0, I don't have a function, and I could never meet criteria number 2. I have a function at 0, but the sum would never be 1, right? So we just kind of keep this in mind. So the second step then is let's set up our integral 0 to 2 f of x, kx squared dx, has to equal 1. So let's integrate that. We'd have, remember k is a constant. I don't know what it is. We're finding that. So kx to the 3 over 3 from 0 to 2. Again, we need that to be 1. I don't know what k is. I need it to be 1. So I'm going to go in and just factor out this k over 3. Right? And now let's substitute 2. So 2 to the third minus 0 to the third equals 1. So I'd have 8k over 3 equals 1, and multiply by the reciprocal, so k equals 3 over 8. And that was all the directions said. Find k, that makes that. So the function, right, the function is, probably should switch colors, that's right, is k 3/8 x squared on that interval 0 to 2. All right. Next one, we're finding the probability x is between 1 and 2 when x is a random variable, RV random variable with density function f of x equals 1/18 x. X ranges from 0 to 6. So it doesn't say verify it's a PDF. So we're just finding this probability. Looking back at that graph I had made, right, if from A to B creates the probability density function, I know that it is, then I could take anything in here, right, from 0 to 6, if I substitute this as 0 to 6, and I want the probability from 1 to 2, well, that's equivalent to just taking that, right, that area from 1 to 2 there, which is equivalent to just taking the integral, right, from 1 to 2. Okay, so 1 to 2, 1/18 x. Let's integrate. We get a x squared over 2, 1/18 x squared over 2 from 1 to 2. And we could just say 136, right? And then 2 squared minus 1 squared. So 4 minus 1 is 3. 3 times 1 over 36 is 1/12. And it's a probability. You know, typically in math, we'd still just leave it a fraction. But in something more practical, we may want that a percent, right? Just do the division, change it to a percent. Okay. Last one. So random variable x has this density function, f of x equals 1/3. One thing to point out here, notice there's no variable. So it has a density function. It's constant right here, y, x, 1/3. So there's our function from 0 to 3. Okay, just to kind of give an idea of what are we looking at. We want the probability is 0.6, so the whole area would be 1, and we could see that, right, from 0 to 3, because it's a rectangle. Base times height is 3 times 1/3. So we get 1, so it is probability density function, it's always positive, and we get an area of 1. So they want to know what is x, so where do I stop? To give me an area, right, I'm just drawing a random number. I need the area to be 0.6. Okay, sometimes it's good to see what's going on, right? Because oftentimes, I mean, with a generic problem like this, how do you know your answer really makes sense? Well, if I got x equals 5, something out here, that doesn't make sense, right? It's outside of the range. Also kind of visualizing 0.6, I know it's bigger than a half, so I know I've got to be past 1.5, right? Okay. Now, we're going to go ahead and use calculus, though. probably could be done this particular one in another way. So now I'm finding b, right? I'm finding this x. I don't know what it is. So 0 to b of the function 1/3 dx, and that will yield me an area of 0.6. Notice in each of these where the variable is, right? What we're solving for changed each time. Okay. So we get 1/3, to integrate 1/3, we just get 1/3 x from 0 to b equals 0.6. So we get 1/3 b minus 0 equals 0.6. So 1/3 b equals 0.6. Multiply by 3, I'll go and write it. Multiply by 3, we get 1.8. And that makes sense looking at, that quick drawing. Not always can we visualize this great, right? If this was some crazy function, not just a rectangle, I may not know for sure that this lines up well, but sometimes, it's still a good idea to kind of visualize what is going on.